All right. So guys, let us now have a look at example one. Before we dive into it, what I'll show you is that a complex number, the complex number Z, is normally written in Cartesian form. I know I have that written somewhere. Written in Cartesian form, it is x plus I, y. That's in Cartesian form. X, the real part of the complex number, Z, is x, and the imaginary part of the complex number, Z, is y. Please note also that x and y are real numbers. So x and y are real numbers. Please also note that the imaginary part of the complex number does not include I. So the real part of the complex number Z is x. The imaginary part of the complex number Z is y. And x and y are real numbers. And the imaginary part of the complex number does not include I. So example one says, identify the real and imaginary parts of the complex number. So A, I would say that the real part of the complex number Z for A is 2, and that the imaginary part of the complex number Z is 3. That's all you have to do. What I want you to do is write the question and complete the write what I've done, write the question and complete the example. Do that very quickly, please. All right, so for B, the real part of the complex number is 4, and the imaginary part of the complex number is -2. For C, the real part of the complex number is 4x, and the imaginary part is 5y. For D, the real part of the complex number is 3x squared, and the imaginary part is 6x plus y. For E, the real part of the complex number is cosine theta, and the imaginary part of the complex number is 2 sine theta. All right, for F, to the left, I is common. So if I factor out I, I'm going to end up with 4 cosine theta minus 3 sine theta in bracket, I outside, plus 2 cos square theta. So here, the real part of the complex number is 2 cos square theta, and the imaginary part of the complex number is 4 cos theta minus 3 sine theta. Any issues with anything here? Anybody?
No, sir.
No, sir.
All right. What about F? Did you do the factorization? Did you do that for F?
Yes, sir.
All right, very good. Very good, guys. All right, let's talk about powers of I. Powers of I. So if everybody remembers that I is actually equal to the square root of -1. That is what I is equal to. So I square would be the root of -1 square, or I square if you want. I square would be root -1 times the root of -1. And if you remember anything from surds, root -1 times root -1 is equal to -1. So I square would be equal to -1. I cube would be I square multiplied by I, but I square is -1. So this is -1 times I, which essentially is just minus I. So I cube, so I square is -1, I cube is minus I. I to the fourth power, would be, if you want, there are several ways you could look at it, but you could say it's I square times I square. As I said, there are multiple ways you could look at it, which is -1 times -1, which is equal to +1. I to the fifth, I could say that this is I to the fourth multiplied by I, which is equal to 1 times I, which is just I. I to the sixth, I could say it is I square raised to the third power. I don't think anybody would have any issues with that. That's the same as saying I to the sixth, but I square is -1. So this is -1 raised to the third power, which is -1. Once you raise a negative number to an odd power, your answer must come out negative. So from this, what we can conclude is that all powers of I can be written as 1, I minus I, or -1. Jamila, you had a question or a comment?
I'm sorry. No. No, sir, sorry.
All right. All right, any issues there, guys? Or can I move on?
Sir, give us a minute, please, so we
No
can write it
problem.
out.
Sure.
Excuse me, sir.
Go ahead.
So I squared equal the root of -1 times the root of -1 equal -1.
Uh-huh.
Oh, okay.
You seen it?
Okay, no problem.
Yeah,
I guess
man.
I just had to say it out loud.
All right, cool. No problem. No problem. I think what you're probably imagining, you're probably thinking it's that the root of -1 is negative, which is not necessarily the case. And then you'd be probably saying that a negative times a negative would give you a positive. But no, that's not the case here. Root -1, whenever you multiply something under a root by itself, you get back whatever is under the root. Or if you want to look at it from a point of view of indices, that was surds, you could go, that you could say the root of -1 square would be the same as saying -1 raised to the half power square. So you could look at it like this. So this is -1 to the half power multiplied by 2. So this is if I'm looking at it from indices point of view. That goes, so this becomes -1 to the power 1, which is just -1. So any way you look at it, I square, which is minus the root of -1 square, is -1.
Okay, sir, thank you.
No problem. Going down a little.
You can go ahead, sir.
All right, good. All right, guys, this is
Sir, can you please
example.
wait a second?
Sorry, Jamil, you were saying?
I was asking for a second to finish writing.
Jamil, you sounded a bit muffled a while ago. I didn't hear what you're saying. Do you want for me to go back?
Yes, sir.
All right, no problem. All right, so example 2, I'm going to do one part of it. There might be some other parts to the question on the next page. So example 2 says, identify the real and the imaginary part of. So let me do A. So I might have to do a little working on it first before I do anything. So this is the same as saying 2 plus 3 times I square, and I square is -1. So this is 3 times -1 minus 4i. All right, so we need to get that in our head, at least, at the very least, the idea that I square is -1. That we need to get in our heads. So this becomes 2 minus 3 minus 4i. This is -1 minus 4i. So the real part of the complex number is -1, and the imaginary part is -4. All right, so I want you to do B very quickly. All right, so this is actually 5i. I cube, I think, is I cube is minus I, so this is plus 3 times minus I, minus 4 times I square, which is -1, plus 2. So here we have 5i minus 3i plus 4 plus 2. So in the final analysis, what we have is that this complex number is actually 6 plus 2i. All right, guys, so I agree with you. The real part of the complex number is 6, and the imaginary part is 2. All right, so let's go to the other side and do the other parts of this question.